I'm going to do a first order linear differential equation initial value problem. Okay. The first step for a first order linear differential equation is to put it into standard form, which this one is. The piece multiplied by y I'm going to call p, and the piece that it is equal to I'm going to call q. Okay. Now, I need to compute my integrating factor, which is always e to the integral of p of x dx. In other words, e to the integral of tangent of x dx. I'm using my integration rules here that says the integral of tangent is minus ln of cosine. And as is usually the case with these problems, I'm ignoring the plus c here because I'm going to put it in the end, and that one absorbs all the previous ones. Now I can simplify this. This becomes e to the ln of cosine all to the -1, and here the e and the ln cancel each other out. So I'm left with cosine to the -1, which we just prefer to write as secant. All right, so now I'm going to go back to my original differential equation. And I'm going to take the entire thing and multiply it by my integrating factor, which is secant of x. So I end up with y prime secant of x plus y tangent secant equals secant squared plus 1, because of course cosine times secant is 1. Now, the reason for doing this is because the left-hand side is now the product rule to find the derivative of y times secant. Because if you take the derivative of the first times the second, plus first times the derivative of the second, we get back to here. This makes it much easier when I actually integrate both sides, because the integral and the derivative cancel each other out, leaving simply y secant of x on the left-hand side. On the right-hand side, I have the integral of secant squared plus 1, which is, of course, tangent of x plus x, and finally I'm going to put in my plus c here. This one absorbs all previous ones. Finally, I need to solve for y, which involves dividing both sides by secant, or, as is easier, multiplying both sides by cosine. Now, tangent times cosine just becomes sine, and then I get c times cosine of x. Now, this is my final, and I'm forgetting my x term. Excuse me, let me go back. X cosine of x plus c times cosine of x. Now, this is the general solution, but it does still have that constant of integration there. And since we were given an initial value, I'm now going to go back to my problem and plug in my initial value to get my particular solution. So, when y is 1, I'm going to have an x of 0. Sine of 0 is, of course, 0. Cosine of 0 is 1. So I end up with 1 equals 0 plus c times 1. In other words, my constant of integration is simply 1. So my particular solution is y equals sine x plus x cosine of x plus cosine of x. And that completely solves the differential equation.